Okay. Today is going to be a different kind of stream. I'm going from a completely scratch operating system, a new programming language that is sensibly designed to the web, and in particular getting graphics on the web. There's not much I despise more than JavaScript. I just hate it. I think it's one of the worst programming languages in the world. At least 50 times a month when I'm doing something completely standard on the web, such as like paying for something, even just browsing, things won't work. Even just last night, I logged into my internet provider and tried to just get a PDF copy of my latest bill. Logging in there were technical issues, but I got around it. And then literally on like the page that said, oh yeah, we need to like verify your identity before we send you the PDF. Every single option that I chose, there was some technical difficulty and it didn't work. It was like, send me a text message, it didn't work. Send me an email, it didn't work. It's just, the web is a total disaster. This said, for my upcoming game, the game is both simple enough and immediately obvious what's needed to happen, that it has the potential to reach millions. And I think, I hate saying it, but I think the best way for it to reach millions is to release some demo of it on the web. This said, since I'm in control of it myself, if I've committed to releasing a game demo on the web, I'm going to do it in my way, which is using a sensible language as long as possible, which is Zig. So Zig compiles to many platforms, but in particular to something known as WASM. And I can basically use this to make sure that when I'm doing stuff on the web, I'm touching JavaScript in as little as possible. Like almost everything I want to do is just in Zig. And then a tiny bit of like connection code gets the Zig stuff to the internet. So for instance, this is like a fractal using a shader that I wrote. And this is like the HTML file. Extremely minimal. You could write this out in 1 to 2 minutes. Very easy. This was generated kind of in 2 ways. This is literally the only JavaScript file that's the main JavaScript file that's generating this. And then there is like this thing. However, this thing is automatically generated. I'll show you how this is automatically generated soon. But the main thing in this script here is that this script is fetching this WASM file. And this WASM file is the thing that Zig compiles to, and basically that contains like all of the logic. Everything in this part is, everything in this Zig, in this extract is just like interface code that's automatically generated. For instance, using this like, clearly since there's a shader running here, I'm using WebGL. To even set up WebGL, a lot of things have to happen. That's why like fragment shader is happening here, like static draw, all of this kind of thing. But the main idea is that Zig makes the WASM file. The web page loads the WASM file in a simple way, and then everything's gone from then on. This was something I like looked into to try and do years ago, and I failed. However, another Zig user, Scott Redig, basically figured out how to do all of this in a sane way, which is using this like Zig JavaScript bridge. So basically, the entire idea about this is you write something in Zig, you include this library, and then when you build the thing, and you build it in a sane way using the Zig build system. I'm not using some like obscene JavaScript build system. It basically like scans the Zig file, extracts like the necessary connecting code, that is, it generates this thing, as well as like compiling stuff to like, and then Zig itself will do like will compile to WASM. I think the currently the core Zig team is working on replacing a bunch of kind of features in that process. I think the WASM backend is not yet fully supported, but there absolutely is plans to. For example, if we go to Ziglang and we go to the kind of like projects, in order to like get the performance really good, basically every dependence on LLVM is going to have to be jettisoned. However, yeah, here it is. Part of this is making sure that there's no kind of LLD linker. So currently LLD is still being used for WebAssembly and like the WASM. However, sometime in the future, hopefully in a couple of years, this will be gone, and then Zig will be its nice own independent thing. Okay, but anyway, back to the topic at hand. Okay, so what do I want to do today? So today I want to get this thing animating. I can show you the code for this. The shader for this is very simple. It doesn't look simple, but at its core it is. At its core, most fractals are simple. Oh wait, I stored this in example. When Emacs loads, yeah, this here is the shader that I'm using. Yeah, my shader that created this thing. Really simple. It's basically just in a for loop, do an operation with some complex numbers a couple times. It's basically just the standard Julia set Mandelbrot thing. Take a complex number, square it, shift it by some fixed complex number, do this iteration a bunch of times, observe how large it's grown, how kind of quickly it grows, and then kind of color the pixel in terms of that. So yeah, so I want to animate this by making the value of the C here, which is this vec2. Maybe I can zoom it. I want to make this thing change over time. However, that will also require writing an animated loop in this thing. I think with like on the internet, writing like a game loop is, as expected, not straightforward. It's like some weird thing where you have to like call some function and then you seemingly call the function recursively, but it doesn't actually blow up the stack even though you're calling it recursively because of some reason. I don't know, I don't care. I just want to figure out how to write Zig code and get that working on the internet. And then, okay, yeah, but yeah, the main idea is going to be using Scott Reddick's, these projects, using this JavaScript bridge. So the first thing we'll do is adapt the build system so that I can type Zig build fractal, generate this thing. And then I want to then study Scott's breaking out of WASM example. This thing itself actually does have an animation loop, and so this will be, in theory, straightforward to adapt to my case. And just to like illustrate what that actually looks like, if we go to like Scott Reddick breakout WASM example, if I do Zig build breakout, do the thing. Whenever I see LLVM emit object, like part of me is triggered, but the Zig team is solving it. Debug builds will no longer have LLVM in the future. When we then go to Zig out and bin, if I just run a HTTP server from here, like this, and then say like I refresh the page, okay, I think I need to like clear the local cache. So I should, I don't want to delete everything here, right? Let's just delete the temporary cached files and pages, which is already 1 gig. No. I want to only delete this thing. Yes. Okay. Let's try again. Okay, that worked. And yeah, so this is a famous game that's got remade in Zig, and almost like entirely in Zig, and then wrote code that generates the necessary stuff in order to get this on the web. But basically without writing any JavaScript whatsoever, which in a perfect world, no one would ever have to write any JavaScript code. But we obviously don't live in a perfect world. Okay. Yep, so I think the first thing to do is going to be to clone the this example, and then to properly import my fractal example into this. Okay, so I'm going to do Zig WebGL WASM examples. This is blank. Let's copy this. It's all there, and then just to show everyone what the default looks like. If we just build the example, it just renders the Zig logo using the 2D canvas web, the 2D canvas API that is standard in most browsers. Yeah, the code itself is basically this stuff here is the stuff that's going to draw the Zig logo, and you can see here move to line 2 fill. It's the standard web API stuff. Yeah, so if we go to Zig out bin, and then likewise do a HTTP server here. When I open this in the local host, we get the Zig logo. So yeah, so the Zig logo is being rendered via all of this code. So notice that there's a sensible for loop. It's sensible. Everything here is sensible because it's Zig. Okay. Okay. And I'm not going to apologize for the amount I ran. I've just literally millions of human hours are wasted every day because of JavaScript. Let's do the calculation. Okay, so let's modify the build script. So we want to do where Zig WebGL examples build. Okay, so yeah, so currently in the build system there's 2 options. There's building the kind of example and then the really simple example. That's not it. Yeah, the simple example. So now I want to add in an additional example, which is this fractal example. So I basically want to presumably copy all of this stuff and then modify it in an appropriate way. But maybe it's good to just skim over the entire build file first. So let's see. First of all, we get the standard optimize option from the command line, and then directories is going to be the standard binary one. I might want to change this a bit later, but we'll do that later. Change this so that it doesn't go, so that it goes into, let's say we want to send it into zig out / like fractal, or rather like zig out example name. Okay. Then we want to generate an executable. So this is it's going to be called generate.js.exe. I'm kind of wondering actually where the build system puts this. I imagine it puts it in like a cache. Okay, so let's see if we can actually find it. Oh, before we do, it would be good to build it. So let's say we do zig build example. Kind of again. And then we want to copy in yeah, there it is. So it's been built in like the local cache, and also, right, the build scripts as well have been too. And then okay, and then we are going to build it here, and presumably, yeah, we're going to have to call this in order to generate the presumably like the extract.js file, the one that which appears. Wrong folder. Oh wait, it's not going to load it because of weird security things. But yeah, it's gonna. I think this is the one that's going to generate this thing. Okay, and then we've got this module thing. The ZJB here, which stands for this JavaScript bridge. This is one of the core things in source. This one here. Should zoom in. And this is, what does this do? I think this is basically the way that we call JavaScript functions from within the WASM, like within Zig. Yeah, like when I made the fractal example, I was just calling like call a lot of times and get these kind of things. Yeah. Okay, so now we get to the building the example parts. So yeah, just make an executable with the source file in the kind of standard way. This part is new to me. I'm not actually, clearly this is the WASM part. I'm not actually sure what the freestanding part does, but again, if the breakout game works, my game can work as well, so it's fine. Then, okay, then we're like adding to the root module something. I think this line is needed because of this thing here when we're saying import ZJB. Although I don't have any experience with what this root module actually is. Maybe it's just, maybe the root module is the place where you do that, but that's purely speculation. Okay, and then likewise, I'm not sure what .entry and .add dynamic are doing either. Okay, so then we generate the JavaScript for the WASM. Okay, so then we call the executable defined above, namely this one. And then we then want to save the output of that to a file. Right, okay, extract example out. Unclear why that's needed. But in either case, okay, are we going to have to duplicate this in order to do the fractal example? I don't. I'm going to have to think about this. So at this point here, doesn't at all depend on like the actual core, like the specific zip code in the project. Okay, which is curious, yeah. So this is kind of this is going to work almost regardless of what you put into it. And then we install it. This stuff seems fairly standard. Like, add example is like a keyword in the build script, and like in the build command, there's a build option. I suppose this is saying just clear out whatever's in there before. Okay, here's the actual write the stuff to JZB extract. This one's just saying copy everything in static to the thing. And then apparently that's it. Okay. So this add install artifact is the main one that's writing the WASM. But yeah, it's still unclear to me exactly where the where the scanning is going on. Like how does this thing get run on the source code in the example? Oh, maybe. Yeah, it's still not apparent to me how this is working. it may be actually quicker just to copy things and just sort of see that they work, and if they work, push later down the line figuring out exactly how this build script works until later. Like I did that with the butterfly app, and then within a couple months was able to just rewrite the build file and kind of understand most of it. So something similar could happen here. No, yeah, I'm not. It's again, like I'm really surprised that perhaps like to this executable we're not passing in like a file name, or at least like the source code even of the .zig file. Yeah, anyway, okay, we will move on, and we will move on. Yeah, but in either case, okay. Let's compare the example with the minimal example. Okay. Okay, so with the actual example, yeah, like define the executable. Add in JavaScript bridge, set entry in dynamic. Basically the same thing here. Okay, and then for this part here, kind of looks the same. We're saying run the exe generated earlier. Do this, which apparently is enough to generate the relevant bindings. Add that. Oh, like maybe is this it here? Like maybe this is the thing that is. Okay, this must be it. This must be the thing that actually runs this thing on the code. I'm just surprised since like example is the executable itself. Anyway. Okay, and then so we'll have to change this to like the fractal, and then likewise the source code up here and other stuff. And then how about this part with this part? Yeah, add in that thing to the build script. Yeah, these lines kind of look the same. And we're saying depend on like the WASM, override the destination, copy in the extract, copy in the static stuff. Okay. Okay, so let's let us add in the fractal example now. I guess we can add this to the bottom. Okay, so let's say our fractal example Okay, we can probably just replace all instances of simple with fractal. But let's just check. So yeah, simple. Okay, we'll need to move the fractal stuff to fractal/fractal.zig. Do all of those things. Now we're extracting stuff from the fractal. And then, oh, hang on. Okay, we will have to change something. Okay. This is something I kind of don't like as well. Like, I feel that for basically all of these projects, for all of these examples, I just want to have like the same like, index.html file that just gets like copied into everything. Make the index.html, etc. gets copied into every project from one place. Okay, so I think the part that's flawed here was changing that part to fractal. Since this is going to be like the example.wasm and oh, what? How? Maybe it's fine. Okay. Maybe it is actually fine. Okay. All right. So now let's make it a directory called fractal. Should zoom this in. Now we want to copy basically everything from the example folder in, but then replace the relevant part with the shader code. So let's just like open up example and open up the fractal. Okay, so I don't think anything in here is going to change. Oh, maybe this is the part where we actually we might have to change something in here from like example to fractal, some like word. That would be really annoying. Let's actually compare this what's in the static folders of the example and the simple and see how closely they match. Because like presumably they should basically be the same, but they may not be. Okay, so this is in the example, and let's go into the simple. Okay, simple static. Oh no, okay, these are quite different somehow. Okay, so this is saying like simple.wasm. Curiously, this has a canvas, but this doesn't. Why would these be different anyway? Okay, what about the... Okay, this has the star, but presumably... Surely this is the same as well. Oh, there's only one thing in here. That's it, just the index.html. Well, okay. Okay. In either case, I don't see anything here that needs to change. I think if anything will change, it will be whatever's left in this static folder, which is the script.js. So I think this thing's going to have to change. But hopefully that should be it. We'll change that to fractal. Okay. Okay. Let's. So many buffers. Let's just go back to. Let's just clear out everything. Easy option. Okay. So. Yeah, so we want to copy everything here over, and then in here we want to modify the static. The script, we want to change the example to fractal. Okay, and hopefully that's it. We'll see. Oh wait, not yet. We need to get rid of this main.zig file and replace it with the actual fractal code stuff. So where is that? And move that to temp, and then zig, WebGL fractal, all of this stuff. Okay, so if we copy that in here, now let's try building it. Okay, so I'm going to do zig build fractal. Oh no, file not found. Fractal.zig, okay, easy enough to fix. Let's move main.zig to fractal. Oh, maybe that just built. We can get rid of this. And let's see. Okay, that's running. So now let's do localhost 8000. Activate JavaScript. But okay, great. Example is working. Okay, so that's like the first task done. Okay, so now this is fine. We can clear out the, we can simplify the build script significantly. So let's, before I do that, let's save this project. All right, since this is like, since this is already a Git project, stuff is already in here. I kind of want to just save this as like a separate thing. So we'll clear this out. I don't want to go like the whole Git dependency thing. That's just, that leads to like code rot so quickly. Let's do, let's clear this out. Okay, so we want to clear out the simple. I think we can actually get rid of like the zone file as well. I don't think we need this. Let's say we call this like build zig.zonex. Okay. Oh, Windows. Yeah, let's just like delete everything and okay. Let's just check that things. Okay, doesn't detect any git, which is good. Let's just build the fractal example without the zon file and the cache. Yeah, that's fine. And let's just completely check it's fine. Okay, that's fine. Yeah, so let's go ahead and delete the simple, let's adjust it. I'm just thinking now, is it better to like save it now in Git and then delete stuff? It's probably best to save it now. Okay, so let's do heaps of stuff in here. Already there's a git init, which is good. So we could do like git init in here. What does status bring up? Heaps of things. We certainly don't want to be saving any of this. So, but maybe everything else is fine, kind of. Oh no, there's some redundant files. Okay, let's remove the script.js tilde, and then why am I not seeing the WASM in here? Oh, because we deleted zig out. Okay. Let's just delete the cache as well. I think everything here is ready to add. Oh, we can get rid of the build thing. Yeah, we'll delete all of this very soon. We'll delete all of this very soon. Oh, what's this like git attributes? I have no idea what that is. Git attributes. Okay. So we should say like, yeah, initialized repo from, let's be certain to give attribution where it's needed. We'll do this later in the readmes and everything, but start needed from the zig javascript bridge repo version but let's format what we're actually writing first. We can just do 6, I think. Repo by GitHub user Scott. Okay. Okay, so now it's in there. Let's just modify the git ignore file if needed so that not everything's recorded. So say we now do zip build fractal, and then git ignore. Oh, maybe most host.exe. I guess we're still remembering the WASM. Actually, maybe it's kind of... The WASMs are small enough that maybe it doesn't matter if we save them. Still... Oh no, we really need to modify this. Ignore all of that, please. And then... on that. And ignore anything that has a tilde at the end. And why is zig out still being recorded? Okay, this is more what we want. Ignore updated okay, so now let's get rid of stuff from the build system we don't need. Okay, we don't need this anymore. This is the one we want. So we don't need this simple example anymore. We don't need this example anymore. We just need the fractal. Let's go into the build system. So obviously we need all of this, but then this example can be jettisoned. Likewise, this can be spaced as well. Okay, and we should totally say like to do note how this file was modified from Scott Regex. Okay, so now if we do zig build help options, we should now only have the fractal keyword like appear as an option. I forget where exactly in all of these standard ones it appears. Oh, here it is. Yeah. Build the hello zig example. No, we don't want to do that. Build a build the Julia set example. LLVM, you take away 1 second of my life every couple of minutes, and I don't like it. Okay, that's looking good. And then, what else? I think it's fine for the moment. Yeah, let's right, we do want to record that we deleted all of these things. Unmodified the build script. Yeah, cleaned up like, yeah, jettisoned other non-fractal. Okay. Okay, so that's like the first task done. Good. So now we're going to have to do the animation part. We're going to have to figure how do we call JavaScript function from within Zig, from within the WASM, to get the Julia set animating. And like this will be worth it. Like the animation looks so sick. I think you can simply just change the, yeah, we'll play with it a bit, but we'll change the in the shader fractal fragment shader. We basically want to change this part. This changing this gives you very different looking fractals, and so in particular we'll want to within Zig take like a timestamp, figure out if the WASM can even do that. Is like the WASM allowed to do operating system calls? I don't know. We'll use the breakout example as a reference. Basically, we want this to be equal to some value determined by like theta, and for instance, maybe we just take a small circle in the complex plane near 0.5, 0.5, and the given point on that circle in the complex plane is determined by theta. We make theta equal to like the time, some normalized version of the time that goes between 0 and 2 pi, and then we'll get a really cool animating moving fractal. Okay, so now it's the breakout time. So let's check out the code for that. Okay, where are we? Here's the code that's generating anything that's needed. Oh, this itself can be simplified a lot too. Okay, I kind of want to clean this up right now. I am kind of tempted. I am tempted in these examples to draw the Zig logo with some like orange triangles. This could be like another example we do a bit later. Because it kind of would be nice in like the fractal example that's animating on the web, just to have like the Zig logo in the bottom right. Because I like Zig, and I think it's the current best solution to decades worth of pain. It's a bold step in the right direction, in a more positive direction. Okay, I'll come back to that later, but yeah, we're going to have to modify this to make it animated. Let's do it this way. Let's clone the breakout example. I feel like I did at some stage, and now I've forgotten where it is. Did I move it in temp? You do want to go to documents, temp. Yep, here it is. Okay, and then the source for this, oh, here it is, yeah. Okay, so yeah, so here's all of the stuff for the main loop in the breakout, and then the game has like, all of this is like, this is so beautiful. Like this is what I need to do for my game. Like, notice in this file, there's like no JavaScript whatsoever. None at all. All of this stuff is just going into the WASM, and without any massaging needed in this core game logic. The main part, this stuff does require, you know, basically calling JavaScript functions from within the WASM, but it's also not too bad. Like it's basically like 100 lines of code, which I think is a small price to pay for being able to just do everything completely in a strongly typed language with the ability to like import C libraries and a bit, you know, all of the massive strengths of Z. So yeah, so we'll do it this way. Okay, so I kind of want to read through this now just to see what's happening, even how this is different from the current fractal example. Let's get rid of the fragmentation. Let's get rid of that so I can do fractal.z. Okay. So yeah, basically all of this is the same. We don't need that in this case. Okay, but here we're calling the WASM allocator. It's the same. Okay. Yeah, it does make more sense to move this down. Actually, I shouldn't really touch the fractal example at all yet, I think. Because, okay, I want to do something a bit simpler first. Yeah. Before we try and sort of do animation with somewhat complicated GL, I just want to get an animation working where the background color is clearing and where that thing's on a loop. So like the GL core for that is what is it? It's like background. Is it like clear bit? Where is it? I think it's this one. No. Oh, here it is. Yeah, clear color. Okay. So I just want to get. I want to copy this, basically delete everything other than what's needed to get this working, and then instead of like 0.3 here, we'll just make this dependent on a like time value. The time value will change, and then the color will blink back and forth. And then once that's working, it should be straightforward to then copy in the stuff from this into another version of that, and in that version we'll get the fractal working. Okay, let us copy that. So let's make this one. Let's make this one called like blinking, or like yeah, like blinking screen. Okay, we're gonna have to change the build script for this, but that is okay. Let's see. In this version, we don't need that. We don't need that. Likewise, we'll call this blinking screen. We want to change this to this one's fine. This one isn't a problem. The problem is the script.js. And we want to change the build script to now include making this as well. So let's jump into that. I think we can just copy and paste. So we'll say blinking screen to do actually describe, or like concisely describe what this does. Where's the how long have we been streaming for? 1 hour. Let's replace all instances of fractal with like blinking. Should be fine. And then here we want to do like blinking screen, and here blinking screen. Let's see. Okay, now let's say we do zig build blinking. Idea. Weird. Line 72. What? Where is there a missing semicolon? Did we copy this incorrectly in some way? Where's like the previous bracket for this? Oh, wait, why is this closing off void? Okay, maybe that's it. We must change this. Blinking screen .z. No need for these anymore. Okay, this is going to require more deleting than I expected. Okay, yeah, so if we are just like wiping this one here, if this one here isn't going to require any vertex, any shader stuff, we can simplify this a lot. I guess there's also no need for these array view example things. I'll delete them once it's working. We don't actually need them. Or I can just delete them now. Okay. So yeah, this stuff, none of that's needed. Not needed. None of this is needed, I think. I don't think any of this is needed. This stuff is not needed. We're not compiling or linking these shaders. Yeah, none of this. We're not looking up in the shaders where particular variables are. We're not making a vertex buffer to hold stuff. Like, I wrote all of this on like several subway trips, and like it didn't feel like it was ever going to end. Eventually I did render the fractal, and it did. I was kind of surprised it was. Okay, so here we can clear everything. The only thing we need is this. Certainly not binding any attributes. We're not calling any shader. We're not drawing any triangles either. Okay, I think that's all we need. Or not. Why is it failing now? Blinking / static file not found. Where? Oh. Let's go back to the build script. Screen.static. Okay. Let's check the WASM works. Zig out bin Python http.server localhost. Activate this. Not seeing anything. Let's delete the temporary cache again. Oh, okay. This is message file not found. What? What's happening? Response expected MIME type blah expected application WASM. What? What did I do? Yeah, what's going on? Did I change the script here? Oh, okay. I was saying obtain blinking screen.wasm instead of blinking.wasm. Yeah, okay, that's. Let's just go with this. That would require in the build script calling it blinking screen. Okay. Let's try again. Okay, I don't see anything like going wrong, but I also don't see any kind of anything on the screen. Is this another case where we need to delete the temporary cache? Could it be what I'm clearing the screen with? I don't need that. I guess I am making it like all gray. Let's just make it like bright red, kind of. And I'm gonna need like several terminals, or this will get driven nuts. Zig build blinking. Launch this. No, it's not working. This is a pain. Why? Is it really? Yeah. Maybe that was something maybe I'm doing something silly with the WebGL. So maybe this stuff, like originally when I was doing the fractal example, I think I did these things and then it was okay. So maybe that's what we need. Aha, okay, fantastic. Phew. Crisis averted. So let's just massively tidy up. Let's just delete so much from this file. And yeah. And then get the blue square blinking. Okay, so yeah, so much can be jettisoned. All of this stuff can go. And then I kind of do want to log something into the context here. You can say like begin calling begin blinking square example. Well, like maybe it's more like start calling WebGL procs, I guess it's functions, to draw a blinking square. I can go I should probably like add in where the where exactly the documentation is at URL. It says to call the following to wipe the, well, to like set the canvas to a single color. Okay. Oh, I guess I did actually add in where this was. This is actually it. This looks more complicated than the one I remember. I think this is what I wanted, yeah. Okay, let's delete everything else. Delete. And then, yeah, this const stuff handle can go. I'm not, yeah, I don't really care about these callbacks yet. For the game, we will. I will absolutely need to. But for here and now, it's fine. I don't see either of those being needed either. is the first bracket for this? This is the end of main. Okay. Here is this as well. Okay, let's check this. This still compiles and runs. Yes. Let's save this. How many lines? Oh, 45 lines. Good. Like it's 45 lines plus magical. Well, it's not magical. Plus the Zig build system. At least to begin with. This is the only one I guess that wasn't the only one we adjusted. I guess Git's not picking up that some files have moved. Yeah. Oh, hang on, all of this stuff is new, it's fine. Git commit made very simple WebGL example of a U square, but from WASM made Z. Okay. It is hot in here. Okay, so now we've got the where is it? Now we have the square. Let's start changing the color of it. That is just changing these values over time. Okay, so now it truly is like the 20th time to check out the breakout example. Is it just called breakout.z? If we go to game.z, there we go. Try again. Yeah. Gonna have to read through this stuff and figure out how to copy it over. Blinking.screen.z. Okay, back we go. Can you ignore that? I think this version creates, there's no canvas by default in the HTML, and instead it's created via here, I guess. I'm not too fussed about that. I'm not sure if there's any good reason to do that. It's fine. And then yeah, what's happening in mine? I'm just saying get the canvas here, and then get a WebGL context from that. Here it's saying get a 2G context, but that shouldn't affect the animation at all. What's the body being used here? Zig bodies JavaScript. That is the truth. Oh yeah, I'm not doing any of this append child canvas stuff. No, not unless I need to. Yeah, we're not doing key up stuff or key down stuff, so that's fine. Then what's like document get timeline? Oh, okay. I think this is how we're doing the time, I suppose. Getting the time from the browser. I mean, this certainly works. I'm still confused why we're not able to get the timestamp from within Zig. This is like, I don't want to have to look up like. Let's just see what JavaScript returns when. Hopefully it's something simple. It's probably not. It's so bad. It's so bad. HTML. What? Get timeline. Is that what we need to do? Is it just like document dot timeline? Okay, let's just see. Oh, hang on. It is just okay. It is just some. Time in milliseconds since whatever that is. Prior to the time origin, the timeline is interactive and it's null. Okay, so. Like, I have no idea what that even means. What is like the time origin? No, as little of this as possible. Okay. So it's something in milliseconds, which is okay for a game, and then especially if it's a float, and then okay, it's not going to be a precise time. However, this is a web game, so it's okay. The demo is the web demo. The actual version that ships on Windows will have a very precise timeline. And yeah, here we end up with like the weird loop thing, how it's like you have to like call like the animation frame with the timestamp, and then the animation frame itself seems to be recursive, like because it gets called again down here. It's so, it makes no sense. Anyway. God, it's Java. It's the worst language. Like one of the insane things about it, and it's like I feel comfortable using that word in this context because it honestly is insane. There's like some functions that can return like different types of like things, and yet at no stage in like the function definition or declaration is there any indication of what these types even are. It's like you can have one function that returns like a byte, and then the same function can return some like struct where like each field is like some like dynamic array of like itself like static arrays of structs or something obscene. It's so bad. Okay, so the last timestamp here luckily is a Zig data type. Hurrah. We're just reaching out initially, well, every frame to get this. Well. Presumably the animation frame itself is going to update this. Yeah, it does. This is the very first thing it does. Okay. This is not as bad as I thought it was going to be. Okay, so I think let's just copy this over. So in the main function, this is called animation frame. Hang on. Given this has a C calling convention, does the name of this have to be animation frame? Right, the request animation frame is like the compulsory one, I think. But I'm not, let's just see. So maybe this can actually be something else. We can name this something else, such as like render frame. And then let's just do that. So I want to do, I want to wrap all of this stuff in something different. So let's like do everything in main. In here. No, go back to where you are. So we want to do, within main, get the canvas, set it, get a GL context from it. Then we want to do the time stuff. And then here we want to call render frame, which we're going to have to use C calling convention to do. Render frame. Emacs. I know it's my fault. I pressed wrong keys on the keyboard. You don't have to throw me so hard. Okay, and then the last timestamp itself is, we want this to be an F64 variable. Come on. No, back to where we were, please. Save that as current. And then, we want to go here. Let's say globals, last timestamp is an F64. And then, initially get that. I suppose JavaScript will then like start paying attention to it. Okay, and then we want to render with it. So now comes this stuff we actually want to put in there, which is just all of this. That happens. Okay, we're gonna have to like change. We do want to like change the color in some way. So I suppose we should be doing that let's just write, yeah, let's just write it, well, I'll write it here. Change the color depending on last timestamp, depending on timestamp. Then we set that, and then we need to like recursively, but not actually like recursively call this function. So where's that? This thing here. Const handle global call request animation frame. Blah. Okay. How we define the global? I guess it's fine. I guess it's part of the JavaScript, the JGB library. Okay. Oh, but this is no longer. We're gonna have to update this to like the render frame. So you want the function handle for render frame, and then what's happening? Why are we like calling this twice in here? I thought this request animation frame is just meant to pass in a timestamp. Oh, actually, no, it's meant to pass in a function. That's right. Yeah. Okay, yeah. So we're saying like window dot this with the function. We can't just pass in the zig function. We have to pass in like what, like the JavaScript like pointer to it. So we're then saying like I'm confused why it isn't just fn handle blah, where the blah here is the render the frame. We can just check out the source code for the bridge. Fn handle. The name, and then okay. So hello me wondering how are things going. I hope you're having a smoother time than I am at the moment, but progress is getting made. I'm currently I want to make this thing change colors, kind of blink blue and pink, but not just using standard JavaScript, since I hate JavaScript, but making a WASM file in Zig, which is a compiled language, and then the WASM will contain all of the magical logic to do that. And then once I get that working, I'll be another step closer to making a game, where when I make the game will get turned into the WASM, and that's all that needs to happen. The browser will load the WASM, and then the game will play. No writing JavaScript code needed. But I'm currently confused as to what some connection code is doing. The kind of like it's not actually like an interface, but kind of interfacing with the JavaScript in some way. So yeah, so we're saying, oh, it's like, what's this? Int from enum and then enum from int. Yeah, I'm not sure what that's doing. Let's just move on. Okay, so let's do this to do now. We actually want to change the color depending on the timestamp. So the timestamp is just a float. So let's do something kind of crude, which is just but simple. Let's just like get the remainder of this. Oh, and we can do that since we're doing this at Zig. We can do this in an easy way. It's like, what's the what's like the compiler macro? It's like which one? It's not mod, it's like truncate. It's like the opposite of round. I guess we could just do the number minus the floor. I guess this is fine. So we can say, let's see, constant delta is equal to timestamp minus floor of the timestamp, and then that will give us something between 0 and 1. So then let's change the red value here depending on the delta. Okay, let's see if this compiles. So I'm going to do zig build blinking. Oh, it doesn't like it. Use of undeclared identifier. Variables must be initialized. Okay. That is absolutely my fault. See, this is like, I wish like I'm not completely opposed to programs running on the web, but I wish like I wish it was like, if it was this rigorous, I wouldn't have a problem with it. So yeah, let's initially set this to be, it's kind of undefined. And now it doesn't know what the gr context is. Wait. Right, since we've defined it in main, but not in here. Ooh, this. If I knew the type of gr context, which I do, it's a handle, because we're working in Zig, and Zig actually tells you these things. Okay, so let's say gr context is equal has type jwb handle, and it would just be undefined to begin with. However, we're going to be setting it here, and then releasing it later, and this should never kind of get called because of this. Okay, that built, great. Let's go into zig out. In which case we get this here. I think we can actually get rid of just the blinking WASM and run the HTTP server. And now the kind of moment of truth. I'm not seeing things. Okay, when I updated a different point, the color is changing, but yeah, I don't see some animation frames going. So we're gonna have to figure that out. Why is it not updating? But this is partial progress. Let's save this. I totally forgot. This one here was the HTTP one. So what did we modify? Just that. We did do all of that. Made rectangle, make square, change color when updated, when refreshed, but not yet animating. Okay, let's figure out this then. Why? What is going on? I don't think it's like a cache issue. It's like the fact that like sometimes it is the problem. Oh, I got rid of. No, I didn't. It's here. Yeah, it is not updating, only when refreshed. Okay. What's going on? By Modern Gay. What a great album. What a classic. Let us just compare with the breakout version. So yeah, so what's happening here? I thought we copied over the essentials, but apparently not. Oh, I'm so silly. I'm so silly. The question is, when is the timestamp updated? Let's check all of the uses of timestamp in this code. It's initially undefined, but kind of stack memory in the WASM set. We then set it here, then we call it, and we just continue to call it again and again and again. Okay. This is the kind of bug that I want to be fixing when I'm coding. Like a simple logical bug. Okay, so yeah, we can just say I feel like time delta is better than delta time. So I'm going to call this timestamp minus. Well, hang on. Yeah. This should be fine. Yeah, we do want to save this, and then yeah, we want to save this. Save the current timestamp. Okay, and then we want to be using the time delta here. I'm taking the floor of that instead, and then I think that's it. Let us build the blinking example. run it. And it's not working again. Let's clear the cache in case that's an issue. No, it's still not working. Still not working. That is so annoying. Yeah, what's going on? I'm not seeing it. But like weirdly now when I refresh it, it remains the same color. Wait, is this even the right one? Oh, of course it is. So somehow we made it work less. How? Is the browser like, oh, it's what? Why is it confused about incrementing get here? This shouldn't be it, presumably. Maybe it is. Huh? Okay, this at least explains. This could explain something. Why does it care about this incrementing get? Is that in this version? No. And this is concerning. This don't handles get is undefined. I could just try again, like replacing render frame with like just the string, the terms that are used here, in case this is affecting it in some way. Okay. No, same kind of things. Uncaught type error, what? Is it because we're like releasing the GL content? Okay, it's a different color now. And there's one less thing error. Okay. Why are we still getting this increment and get crap? Let's just like get rid of everything. Oh. What? Why can't I get rid of that? What? Like what? What's going on? Windows, I want to delete this and you're not allowing me. What's using this? I guess that's using it. Okay. Please build blinking. Like this shouldn't be the error, but I'm just with anything web related, I just have no idea no one knows, no one has any idea what's going on. Python HTTP. We don't want it here. This is what we want. I need, once the animation is working, I don't have to touch JavaScript again. Okay, simply by just clearing out the cache, stuff's worked. This is what I mean. You just things. Yeah, it's just this is the insanity of the web. Okay. This is blinking, which is great. Blinking a bit too fast, a bit too much energy, but we can now adjust that. And I have still no idea why. Who cares? Who cares about this? It's working, that's the main thing. So, let us turn down the energy. Let's turn down the energy by multiplying the. Actually, we want to put stuff through like a sine curve to just make it a bit smoother, which is easy to do in Zig. Let's see. I think in the Zig standard library, like standard.math.sine should do the trick. So. Let's see, if we're going to do sine of something, that is a period of 2 pi. And so we want to, before putting it into a sine function, expand out 0 to 1 to 0 to pi. So we say like delta normalized, or we can do it. We'll do it inside the function. Let's just say smooth or like oscillating. Let's call it oscillating value. Oscillating value is equal to standard.math.sine of standard.math.pi 2 times pi times the delta, and then let's put the oscillating value in between there. Okay. Now let's build it. big build blinking. Oh. Okay, this is like serious error. I mean, it's not that serious. There's no number named pi. Really? Really? There's absolutely a pi constant in the Zig code. In the Zig standard library. If not the compiler. Let's see. Dot lib standard. Maybe it's just like dot pi? What if it's in like the math library? Yeah. Oh, it's just literally. Oh, it's not capitalized. Even though it is a constant. Let's try. Okay, that worked. That compiled. Compiling is very different to working. And yeah, suddenly it doesn't seem like it's working again. It's not oscillating too slowly either. Let's just clear the temporary cache and try again. Ay, what's going on? Disappointing. Okay, it's like blinking weirdly. Okay, I guess, okay, maybe it's because like the value, the sign function itself is returning negative values for some of this. And so maybe that's stuffing things up. It really should be 0.5 times 1 plus this thing. Let's try that then. Okay. Still kind of surprised that it's blinking so rapidly. I kind of want to log this. Let's just do log oscillating value. Yeah, it's just. Yeah, what? Yeah, what's happening here? I like want this to stop. How do we stop the page from loading? Yeah, this is changing really, really quickly. Like it's almost changing chaotically. What? I've been assuming that the float that the time returns is formatted in a certain way. Oh, that's right. The time is in milliseconds, not in seconds. That explains everything. Okay. So, in order to get seconds, we want to then divide this by 1,000. This changes how we do things. So I think we want to do like fraction proportion. The time delta is in like milliseconds here, so really we want to divide this by 1,000. Note the timestamp is in milliseconds. Okay, at least these are not moving super chaotically, it seems. But they don't seem to be... Okay, they seem to be oscillating, but like... oscillating way too many decimal points down. Okay. What? Let's just see what it is. We need to. I need to know what numbers JavaScript is returning. Let's just log that. Let's just make the oscillating value fixed for now. And instead, let's figure out what number the timestamp even is. So let's say, let's just assume that this actually still is milliseconds. Let's just log the timestamp. Unused local constant. All okay. You do that, browser. Okay. Okay, yeah, so this is... Numbers are jumping around. But the bigger number is... It does seem to be in milliseconds. Yeah. Yeah, there's a couple of things going on here. Okay. Let's just do time seconds is equal to timestamp divided by 1,000. I'm so over this. So over this. That is behaving as expected. Okay, so now we have that. Let's save the last timestamp in seconds. So the last timestamp seconds is equal to the time in seconds. And then actually, what is this? Now we've got that, we can do the delta. We can say delta seconds, which is now just the time in seconds. Well, this just to like stop weird, some weird initial spike because of like an undefined value, I think we want to like set this before we actually call the frame. So we call it here, and then we want to say this is equal to the last timestamp divided by 1,000. Okay. Then we can sensibly say all deltas, including the first, is the time in seconds minus the last timestamp in seconds. Then we want to update the last timestamp in seconds with the current time in seconds. Okay. Now let's log the delta seconds. Like, yeah, sometimes with these things, I think it's just easier just to like start over instead of like intersecting all of these bugs. Yeah, this is shadowing it because it's meant to be not. It's meant to be the same. Undeclared 38. So we can just say this is that. Animation frame. Times. What do we need to call? 39. Why is this still? Okay. Let us try again. No, and now it's like, what on earth is going on? Have I just recreated this error? Apparently. What? What is going on? Oh, right, because all of these are the deltas. Okay. So if anything, this is showing the kind of accrued frames per second. Okay. Wait, why am I even like calculating the delta to begin with? I guess you need to do the delta for like smooth animations, but I don't, it's fine. I mean, like, okay, we don't actually need the delta. This is embarrassing. Okay. So now we've got the time in seconds. Now we can just plug this back into what we had before. So now we can say the oscillating value is 0.5 times hang on. It's sine, so we want to shift the sine by 1 and then multiply it by 5. Yeah. 1 plus math dot standard dot math dot sine of 2 pi times t. So the time in seconds times math dot time. I kind of want to write it the math way. I know how to do this. Let's just say time in seconds here. And then, since this is Z, which is a sensible programming language, at the top here we can just say pi is equal to standard dot math dot pi. There we go. Okay, this should be done unless I forgot something like a bracket. Okay. Finally, after like a bajillion hours, we have something that's blinking. Hoorah. Okay. Wasn't expecting such a dumb times 10 pockets. Like, we're just calculating the time between each frame. Why isn't that oscillating? Okay. So this is good. This is very good. So let's just save what we've done, and then I still have enough energy, I think, to now copy the frame animation stuff here into the fractal example, and then which will be the reward. Then we're going to get like a super cool animation that's playing, and basically when that's done, that's like, once I can get something animating using WebGL but completely controlled by Zig, it's, you know, by like half of the game is done. Half of porting the game is done. The other half is then, or at least a remaining third is doing keyboard input and dealing with JavaScript to like figure out when someone has pressed something on the browser, instead of, you know, just like bit masking a map of the keyboard, since that would be that's too complicated. And then the essentials are done, and then it's possible to make a web game directly by typing Zig build game and pressing enter. Everything is generated. No need for Inscripton, no need for like Unity web plugin, no need for any ridiculous thing. The Zig build system is all you need. Okay, so let's and Scott Redig's library. This is Scott's beautiful library. So let's save this. Status new. Let's see. Got square blinking. Blinking blue pink. After We'll leave it like that. Okay. I should block the Twitch spammers. Let's see, where is this person? How do we? I always forget this, right? It's like, where's the moderate? I like forget this every time. It's so annoying. Oh, do I have to click them? Oh, that's right. And then I do like block. There we go. Of course we're blocking the spammers, obviously. Okay. Presumably like good. The spammer is blocked. Okay. So finally, time to do the fractal. we are getting there. So yeah, so if we do zig build fractal, well, we've already built the fractal, right? Zig build fractal does that. If we now switch into now if I do Python like this, okay, not loading, even though fractal WASM is there. I wonder if it's another local location. Yeah, it was a local cachening. Now I want to get this animating. So let's copy over into the fractal example the animating code stuff from the blinking example. And then I guess to begin with, I'll just make it so that like the pink here in the background is blinking into the color. However, the real power will begin once we update the shader to take in a uniform like theta, and then theta will control the value of C used in the shader. We'll have to look up the like WebGL documentation as to like how to access like the uniform in the shader once it's like compiled in the WASM, but it should be straightforward. It's like, yeah, it won't be harder than dealing with an embarrassing timestamp bug. Okay. I didn't just like stuff that up, right? That's fine. Okay, so onto the fractal example again. So here we're going into the fractal.zig, and we're gonna have to copy stuff over. So I think in a similar way to before, I can kind of wipe all of this away, except the data I want to use to like eventually draw the Zig logo. Let's save this in somewhere separate. I don't think I actually need to save it anywhere. Right? Like, what does it look like again? If we go into the temp and the Scott, like I copied stuff in here. Let's just wipe this. Okay. Now if I do zig build example, and then I go into the zig out, and then I do the Python m. I have to do the thing. Yeah, it's okay. since the code's already in here, like who cares? We'll clear all of this out. So deleting. We can delete all of everything here, including the increment and get. And then we want to all of this stuff can go. I kind of just want to copy this main function as using. There's nothing in here specifically that depends on the fractal stuff. Yeah, so let's just copy that. And we'll delete this. At least everything up until here. Likewise, we want to call this, we want to wrap this up in the animation frame. What am I doing? Then copy this over. I feel like this error, this log message should actually happen like here, just before we're about to start calling. I should say start the main render loop. I kind of like a gap between them. Yeah. And then, okay, so now we have to, some of this stuff is like setup stuff that like I don't want all of these, I don't want to have to call all of these things every frame. And like comp time can't work on them. So since the geo context is something we spin up a bit higher. All of this stuff can go. This stuff is going to have to be moved. So I think we could actually just create all of these as globals that we never intend to modify, and we just set the globals in some like init loop, and then they're set and just get called every time this thing. Whoa. Like some of these are simply used to set up the shader and are used at no other stage. So I think if anything, we should create a new function that's like init shader. this is more making the fractal animators more work than I thought, but it's not that much work. You know, we need to like copy the handle at some stage as well. So let's see. Look at that. So maybe here we say like init shaders, but then we'll have to make a global for the shader program. But actually, that's kind of fine. We can just say a variable is like shader program. This is just another bridge handle. It's maybe even a const handle. And then let's do like init shaders. This is just a pure Zig function, and no need for C calling conventions. Let's do init shaders. Void. And then here, we'll want to copy stuff over. So in particular, maybe it's not the best way to split the screen in that way. All of this stuff can go, since we only use it here. Yeah, like constant function args, and then what else? Yeah, we're setting up the vertex and the fragment shaders. Then, okay, so then both of those get compiled, but we want to check that they actually decompile and raise an alarm if they haven't. Get rid of all of that. Then yeah, and this is the part where we need to assign this to our global shader program. So creating this, attach this and link it, and then we want to check that it did actually link. Okay, so then we now have everything actually compiles, a shader program that we can use in the loop. So what are we to do with these things? I think like I'll move these out of the loop a bit later. I just want to get it compiling fast. Move these to a global variables. Okay, so we do that, and then some of this still looks like setup stuff maybe. Actually, this is fine. Like all of I mean, in this case, we actually only do need to call a lot of this stuff once, so probably would be fine. At least for this case. I want to do another example where the position data here actually is changed. But I think for the moment this is okay. So yeah, here we're sending the data to the GPU. And then why are we like clearing all of this stuff? And then we actually draw it down here. Okay. Yeah, I don't like the idea of just like calling so many of these things that we don't need to call repeatedly, but let's just get these out of the way. At the very bottom of all of this logic, we need to call this thing again. And then for like the clear color calculation, let's modify this as well. What's happening with the indenting? Don't know what that's doing. Maybe that's like legacy. Something before it was refactored. Likewise, I can go gl get attribute location. Okay, let's try and compile this. Zig drill fractal. 87. What? What's happening? Why does it expect to type here? Yeah, what? a rare moment where the Z compiler isn't totally clear as to what's going on. Could it be this issue? No. How am I meant to figure out what's wrong? Oh, it's because there's a semicolon there. Damn it. Okay. Likewise, let's copy the pi. Oh, we need to copy the last timestamp in seconds as well. Let's start setting out some constants. And then okay, that compiled. Let's clear out the cache and reload. Once we actually go back to like where it is. Pop did. Try again. Load. Okay. Not seeing the background animate, but that's to be expected because this entire thing, the entire shader, the shade is riding over everything. That is unless we change the geometry, which we can do. So let's go to the array. If we make some of these, say like 0.9, let's make everything 0.9. That should like leave a border, and the border should be changing color. But it's not. Why is the border not changing color? Am I actually using it at all? Oh, I guess I'm not using the timestamp at all to change the color. Oops. I could have sworn I did. Yeah, I feel like I am. Oh, wait, I'm calling clear color several times. Don't. Massive don't. Okay. Aha! Fantastic. Okay, this is good. We are very close to getting the fractal itself changing. Okay. Let's save the work. What has changed? What did we change? Yeah, I don't know why like the blinking screen has changed, but we'll add the fractal stuff. Made background, made border of fractal, blink, change colors. And then what did we change in? Oh, I guess we did want to change this. in the linking string, move log message. Okay. We are close. We are very close. So now we're going to have to look up the... Oh, there's so much work. Okay, I should probably actually... How long have we been streaming for? Nearly 3 hours, which is okay. Yeah, let us. Yeah, let's look up the WebGL documentation and figure out how to add a uniform into how to obtain the location of a uniform in the shader. So what do we want to do with the shader? We want to replace this negative 0.5 here with something. So I want to have a, it's going to be a theta, so it can just be a float. And then we can just take like, in the shader itself, we can just do like a sign calculation to like, you know, put the value of C on a circle in the complex plane. But I need to know how to declare a uniform in this shader. How do we do that? Let's clear all that out. So we can do WebGL stuff like. I think this is the one that starts using shader info. So, but like, right, since this is just like a pure JavaScript, like ridiculously, like the shader source is like embedded in some like string without, like come on. That's why one of the reasons why we're using Zig. We want to, right, like, not Zig. Zig, like, or rather like, without the power of Zig, with the power of Zig, it's just usual shader. So I think it's just uniform blah what it is. So if we go uniform type theta, I think that would be fine. And then the shader itself won't at this stage care about the theta. However, yeah, what would be an easy way to set it? We may as well write like what the shader actually is now. No, there's no, we can do it. There's no harm in it. But the kind of, I don't want to be debugging the shader in a browser. That's kind of obscene. Let's just get the actual shader working first, and then we'll import it, and then we'll do the Zig stuff required. So yeah, let's copy this in here. Ooh, okay, this is rendering in code live, which is positive. Not as large as I thought as I wanted it to be. What's happening? Yeah, this kind of looks maybe one is fine. Nah. Oh, it's because let's see. Let's make the resolution of this 1000 by 1000, and then we'll just like manually set it in here. Okay, and now I can shrink this a bit. Yeah, that's maybe try to. Okay. So now we want to put in the theta. So let's. I think in code life we can control the theta with time, or we can just create a time itself. It's been a while since I've used this program though. Time for a refresher. Okay, a time seems to be going up. So can we actually just say time? Okay, it's compiling. And what if I change one of the colors here to be time? Okay, it doesn't like that, but it's let's do the same thing of saying like a float theta is equal to 0.5 times 1 plus sine of time, and then let's save the theta in here. Okay, the color's changing. This is working. So now we can use the theta here to get the thing moving. Okay, so we want to like define a constant vector. So let's call this like c, and the c is going to equal this. I mean, just it's standard math, right? We probably could actually just take the sine of time what we should really do is have like a normalized theta. Okay, let's actually just define theta in terms of the time. So we'll make the theta like, how do we write constant pi in the shader? Doesn't like it. Surely pi is like a constant in some shader. Like, this is ridiculous. GL shaders constants. Constants in GL shaders. I'm kind of wanting to use the LOM. What if I just do OpenGL pi constant? I mean, hello. What? Oh, come on. Are you serious? Are you serial? Are you serious? How? How? How is pi not defined in a shader? This is obscene. Totally obscene. Totally obscene. This is so ridiculous. Okay, constant float is equal to this, rather constant float pi is equal to that. And then, yeah, theta is going to now be 2 times pi times the time. And then what we want here is sine of theta. Okay, and now for the reveal, we now say this is minus c here. Oh yeah, check that out. That's really quick, so let's slow it down. We can slow it down significantly. Okay, I don't actually need time, truth be told. I wanted to check it out. Oh, maybe it can just be time. Yeah, I'm happy with this speed. This is a satisfying speed. But let's. Oh, if anything, I kind of want it slightly. I want like more of the like actual. I want these Julia sets to be connected more of the time. So let's adjust where the C is going. Currently this is going from what, like 0 to 1. So let's make the radius of the circle slightly smaller. Okay. It's still going out a bit too far though. What if we made it like 3? It's now a bit too symmetrical. What if we offset this a bit? Vec2 0.1, 0.1. Was that still kind of symmetric? What if it's like 1 and then 0.3? Oh yeah, this is more what I was thinking of, but now it's a bit too wide. What if we make it like 4 instead? Yeah, this is past my threshold for coolness. I'm happy with this. Almost. What if this is like 0.2 instead? Oh, no, it's not as. What if you make this like a 4? Oh, but then it goes back to 0. Oh, I see. What if it's like 6? No, too far. Too far. You know, I'm okay with this. I am okay with this. So let's get this. The background doesn't need to be theta here as well. We can just make this SCP. Oh, but the background kind of does look better with theta though. Well, does it? I'm now wondering. Oh wait, no, this color is way too high. This is just getting rounded off to 1, of course. No wonder that's like looking the same. I don't know. It does kind of look cool with the black background though. Maybe we could do. Maybe here we can do float. Theta 2 is equal to 0.5 times 1 plus sine of time. And then we can use theta 2 here instead. I mean, this is. I think this could be okay. These are in sync, though. What if we multiply this by a non-rational number? Everything's rational here. but pi is like sufficiently not rational. So if we have like, if we multiply this by pi actually, pi times time. Ooh, now it's changing too quickly. And I don't want to divide by pi, since that is not a good operation. Yeah, but it's a shader. Maybe it's multiplied by 0.25. And now this strikes me as slightly too quick. Oh, spelling, that's not there. Yeah, this looks good. Let's go with this. Okay, the shader is working. So now let's get this working in the browser. There's going to be some compilation issues, but that is okay. We will solve them. Okay, so first of all, let's remove all instances of the time float here, and instead make it constant to begin with. Let's say float time, let's just make it 0.5. And we'll see if this compiles. I feel like it's not going to though. It's because I think it's going to complain whenever we're mixing types, because the shader will interpret like an integer multiplied by something with a decimal point as an integer multiplied by a float, and then get confused. But maybe it's okay. Let's see. Okay, so we want to compile zig build the fractal. Okay. Now we want to HTTP server this, and let's check it out. Nope, that's not what I wanted at all. Wait, what's happening? I am very confused. Like, let's just clear zig out. Why can I not press delete? Okay. Zig build fractal. The fractal WASM is in here, and wait, what? What? Did I swap them around somehow? Well, that's fine. Oh shoot. Okay, maybe actually this is the fractal one. It's just the shade is failing. No. Wait, yeah, what on earth is going on? Yeah, we like replaced all of that stuff. So let's say we like move it back to what it was before, and then we build it again. Okay. Get rid of this local cache. Run the server. Okay, that's fine. So when we copied the stuff over, it just stopped compiling. I mean the maybe this needs to be done with more care. Okay, so it's here. So then surely we can just add these in. And this shouldn't, surely we can add those in, and yeah, and it still compiles and works. Yeah, well, oh wait, why is WebGL buffer printing so much? What log message do we have? Oh, yeah, that doesn't need to go anywhere. Oh, we're logging too much. Same weird error, but whatever. And then let's add this stuff in. So oh, I guess since it's like a uniform, we can't set it. I could see that causing something to crash. Yeah, like say we set one of these colors just to be time now. Presumably it's just going to remain like 0, but we'll see. Yeah, so it's just it's red because it was set to 0, so that's fine. Okay, so now let's get the uniform updating, and then we'll add in, then we'll deal with the rest of it. I mean, it kind of should be fine, right? It shouldn't. We should just be able to. Oh, hang on. I can see. Okay, I can see if we are doing the iteration loop with this thing that's undefined. If it's some like weird, there could be a problem. Okay, we'll come back to this. For now, it's going to be back to now. It's like now that it's working again. Yeah, we want to do the web geo context stuff. So how do we access the uniform? Tell me how to update this. Okay, so if we check out like uModel view matrix, uModel view, this should describe what to do. GL position. Oh, here it is. So we have to call like get uniform location. So at what stage do we do this? Is OpenGL going to care if this is like after things have been bound or not? I don't remember. Let's kind of do it at the start, and I would be surprised if things break. It's. I feel like I have a memory of things not necessarily working. Maybe we'll do it after all of these things have been set. Or maybe this is the key here. Do we use it before or after the use program button? I think we want to set it afterwards. So let's do. So kind of what we want to do is, if this was JavaScript, we would say, I mean, we kind of are calling this JavaScript function. GL uniform location shader program. Well, in our case, shader program. Then the name of the float, and so here we're just calling it time. However, since we're interfacing with JavaScript, we need to convert everything in the appropriate way. So there's like there was like a constant string in some of the like. I think this is what we do. So I think I want to say like time string is equal to this, and then here we have to do GL context dot call a uniform location, then the arguments, which are going to be the shader program, then the time string, then the kind of other arguments, and there's none. Okay, and Wait, this is returning something though. This is of course not a void. It would presumably be a JavaScript bridge.handle. And we could just say time uniform location, just similar to that thing. Let's see. Model view matrix. Then how do we update this thing? Oh, I think this is it here. Yeah, set the shader uniforms. Okay, so now we want to do, let's move it this way. So now we've got the time uniform location. We want to do, this is a void now. grcontext.call. What is it going to be? It's going to be like uniform float. Presumably it's uniform float. Oh, let's just check. gl uniform float. Oh, maybe it's like uniform, like FV. Oh, here it is. Okay. Oh, no, we absolutely don't want that. We just want a single one. Yeah, uniform, like presumably this is what it is in GL. Uniform float 1F. You can check. Web GL uniform float 1F. Okay, but, alright, oh, it's even easier. Okay. It is just uniform 1F, possibly V. What does the V do here? No info to be found there. Where was I? Where was I? Yeah. Oh, it's like a pointer. No, we don't want to be doing this. Yeah, no need for that. Okay, so that's just all it is. And then but it's kind of more to it than just like, what's this extra argument doing? Oh, actually, it kind of is. It is just those things. Okay. So time, uniform, location, and then the value. Ooh, okay. Now it's important to get the value right. So we want the time in seconds now. And that should update it. Okay. Let's build this, but expected type found F64. Right, because I didn't actually specify that this is a void. Okay. That's moment of truth. Oh no, it looks like it didn't compile. Damn it. But then it said shader link successfully. What's going on? What's going on? Like, is it actually rendering and I'm doing something silly? Let's say I don't call the time at all. Is it okay? No, it's really not okay. Let's say I don't call that. Unused local constant. I know Zig. No, let's just say I log the time in the form location instead. There we go. No, what's happening? Not liking it one bit. Is it because me setting the uniform location is destroying this? Maybe it's just an ordering thing. Oh, but no, that makes no sense. I just uncommented it. But I am calling this here. Okay, let's try moving this above use program. See what happens. Yep. Undeclared identifier time string. Yeah. This is simple enough that we can just use it here. Okay. No, it does not like this at all. Maybe I'm doing this in the wrong order. What have I actually modified? Oh shoot, it may be like an F64 and F32 error or something like this. Yeah, if it's assuming the float is F32, that could be stuffing it up. But I don't understand. I thought I'm like, let's just like comment out everything, and just want to make sure when it's commented, I get the fractal again. Because if not, I have no idea what this behavior is. No, I obviously want Dvorak. So yes, both getting the uniform location and setting it is now commented. So when we build the fractal, okay, the world hasn't ended yet. So yeah, it may be this. Let's just turn these on one at a time. So is it going to just fail because we're simply finding out the location of the time? And then log it. It does. Why is this making it fail? Is it because this is like a constant string? Because I don't actually know what the constant string is doing. This is purely just like guesswork. Like I hate this. This isn't even programming. This is just like guessing. 100% of programming with JavaScript is guessing. I kind of want to sit down now. I've been standing for too long. Way too long. Okay. Way too long. I need to get lunch soon, eventually. Yeah, why is this bad? Maybe the references will help. Like, even before that, where did my go? Yeah, this to me looks like, does this disappear when that's not here? No, it's still there. Well, this says like, this time it's like increment and get. However, yeah, what? Chord or uniform location is not a function, link error. What? That actually does look like a useful error message. Okay, so it's saying uniform location is not a function. What? This better not be because of some spelling error. I'm going to be so pissed. Wait, I think it's because it's literally get uniform location. Let's try again. Let's just try again. Okay, it's working again. Okay, so now we've actually got that. We can try updating it. Ooh, but is it a well, we can now try setting it. Okay. Maybe there'll be a another incorrect function in this. No, that seems to be okay. Okay, so now we've updated. Apparently we're updating the time, so now we can use it. So let's change. I think we should be okay almost to start doing stuff with this now. Let's try and define a theta. Oh, but once we like round, we need to round everything, right? So let's just say theta equals. At this point, let's kind of normalize it. Sine of time, and then we'll start making the color change here. Okay, and then we want to make sure we're actually sending an F32. So we want to say const time seconds F32 is equal to float cast times seconds of 32. Okay, another moment of truth. Okay, this is. I don't think that's what we wanted. Yeah, linking failure. That's why. So because see everyone, this one is not a float. This is an integer. Would you know? Okay, we're updating a float. Okay, we are so close. So let's drop the unnecessary log. And likewise here, so we just like set the time uniform in fragment.gl. Okay, so now we can get our cool fractal going. Then it will be good to save this on. I think at this stage I'm just gonna push it on GitHub with like minimal documentation, and then next time when it's gonna be a while before I stream though, as in it's gonna be weeks. I feel like I should do the responsible thing, and we'll do something halfway. Yeah, I'll get some of the documentation on GitHub. I'll let people in particular channels in Discord know about this. And then when I've fleshed out way more examples, including an interactive one, then I'll publish that. Then I'll make it clear that it actually is finished. For the moment, it will remain in development. Okay, so now we've got the time. So now I can just really say this times that. And then let's define the theta 2. Then we need the C. No, that's the C. Okay. Let's see what it looks like. Aha, there we go. There we go. Would you look at that? It's animating in the web. Let's just see how much my GPU is dying. Like it's not dying too high, too hard. I mean, granted, this is being rendered at 144 hertz in a browser, but then it is only like 500 by 500. I don't know. Oh, it's also because we have code life running. Like this is okay. Yeah, we don't need to say that. Okay, this is way better. Way better. Only 10%. Okay, let's change the like 0.9s that were around into the ones. So we make it full screen. Okay. And yeah, this we finally got there. It took hours of pain, but this is a solid base in which to start making a game. Like, yeah, once interaction is added, everything else is just straightforwards. I think basically. There will be some more OpenGL calls and stuff later, but yeah, this is a good starting point. So yeah, so git add everything. Made like fractal Animate in the browser. Okay. So now it's time to get this on GitHub, basically. Actually, maybe we should clean it up more. We really should. Okay, so what's next? So I think in this README, I want to make it clear that actually, I think I'm going to stop the stream here. I want to go and I want to get lunch. The rest of everything else that follows is boring. It'll basically be me adjusting the README file and uploading it to Twitch. I mean, yeah, well, uploading it to GitHub. Yeah, no more programming is going to be going on today. Okay, I'm going to call it here then. And yeah, thanks everyone who dropped by. I'm feeling, for a while I thought it was basically impossible to from scratch and get any kind of complicated game running in the browser. Like I have no idea how like anyone like at Unity or whatever would like make a plugin that seems to work some of the time. But no, Zig came along, or kind of Inscription came along, and then Zig came along, and then yeah, Zig will hopefully remain, and doesn't matter if Inscription dies because Zig will be able to output its own stuff, and doesn't matter what JavaScript libraries get changed in the future because the WASM will still exist, and provided the WebGL API doesn't change significantly, the WASM will still work. And even if it does, we can just recompile the WASM after slightly changing some of the API calls. And the game will still work. That is actually how you make updatable web games, not like Swift compile blah. Anyway, enough ranting for me. I'm hungry and tired, and but a bit satisfied because I got this working. Thanks everyone who dropped by. See you later.